Hello, this is William Dodds for video assignment number 3. My question or I guess my problem is, a pen cartridge is depressed into its spring by 1 centimeter, and the cartridge has a mass of 2 grams. The friction between the cartridge and the outer wall of the pen has a coefficient of 0.1, and the pen is at a 45-degree angle from the horizontal. The question is, how far up does the pen go before it falls back down? So a few equations you will need for this is one, the sum of initial and final kinetic energy with potential energy. And yeah, you know that initially it starts from rest and it'll end at rest. So both your T1 and T2 are 0. And you know that the sum of all other energy should also be 0. That energy being, one is friction. The friction force will act normally from the surface, so not along the weight, and that's where the cosine comes in. Because it acts normally, the normal force will be less, and you multiply that by mu k times the distance to find the lost energy due to friction, and you know that the gained energy due to its height changing is going to be the negative weight times the change in height. So you'll have to do trigonometry to work out, how much energy is gained there. And finally, you know that all of the spring energy, which is compressed and released, is lost during that time. So you know that the final is 0 and that the initial is just, it's 1 centimeter. And, oh, I think I erased it. Anyway, the spring constant here is 600 newtons per meter. So that's how you'll find that energy. And yeah, the sum is 0. You can work out how far it can go up from there.